So one of the method to measure the efficacy of wetting agents is contact angle theta. If you can measure the contact angle, higher the angle, higher will be the wetting. Simple. Higher the angle, higher will be the wetting. But for the contact angle is very good for studying clear solutions. If the solution is turbid, in that case measuring the contact angle is very difficult. Remember this question. If the solution is turbid, in that case measuring the contact angle is very difficult. Hence we will go for the Drave's test. Hi, today we are going to learn about Hlb values, hydrophilic lipophilic balance, in the context of GPAT. In a short way try to learn this. So before starting, what is this Hlb value, hydrophilic and lipophilic balance, you need to understand about amplifier. What is amplifier? Amp means both, philic means loving. It has love towards both the phases, that is oil and water phase. So it will be like this. The chain indicates carbon chain. If this chain length is more, it will go towards oil phase. So it will love more oil phase. If the strength of your polar group increases, if the strength of polar group increases, it will love water phase more. If the strength of non-polar group increases, it will love oil phase more. So to get oil in water emulsion, you need to take a amplifier which has more love towards water, because you are keeping water as a continuous phase. Remember this. Or to get water in oil emulsion, you should take a amplifier which has more love towards oil phase. Then only it will keep that oil phase as a continuous phase. Okay. So there is a statement. Okay. So if you want to make a continuous phase of particular thing, you should take a amplifier that loves that continuous phase more. Then only you will get that continuous phase. Remember that one. Next, we will move to Hlb scale. Griffin is the scientist who coined this Hlb scale. It is an arbitrary scale. What do you mean by arbitrary scale? It doesn't have any units, no centimeters, no degrees, nothing. It's just a pure value given to that scale. So that value ranges from 1 to 20. What Griffin says is almost all the surfactants will fall in between the value of 1 to 20. But we have sodium lauryl sulfate, SLS, which has a value of 40. SLS, remember this, SLS it has a value of 40. Strong detergent, it has a value of 40. But particularly almost all the surfactants fall within this category. Now we will see one by one what are the different things which are there in the Hlb scale. So if you take from 1 to 3, if the values are from 1 to 3, the thing which fall under this surfactants which will fall under the value of 1 to 3 are anti-foaming agents. Anti-foaming agents. Example, fatty acid alcohols like stearyl alcohol, cetyl alcohol and cholesterol. Next is wetting agents. Next is water in oil type emulsion. Water in oil type emulsion, its value range from 3 to 8. 3 to 8 water in oil emulsion. So remember, in the Hlb scale, if you go towards right, the lipophilicity will increase. If you go towards left, if you go towards right, the hydrophilicity will increase. If you go towards left, the lipophilicity will increase. So because the lipophilicity is more towards left, we are still in the left, we are in the left side of the Hlb scale, hence we are getting a continuous phase of oil phase. So example for this is alkali metal soaps, ammonium soaps and triethanolamine. These are the examples for this phase. Next we have wetting agents. Next value is 7 to 9. Wetting agents. So wetting agents, what are the wetting agents? What happens in the hydrophobic substance is, if you see the surface will be like this. Air will be entrapped on the surface of the hydrophobic substance. Due to this air entrapment, there is no contact between the water and the hydrophobic substance. So the contact angle is very less. To increase the contact, we need to use these wetting agents. If you use the wetting agents, these wetting agents will displace the air from the surface of the hydrophobic substance, hence increasing the contact angle between water and the substance. So, one of the method to measure the efficacy of wetting agents is contact angle, theta. If you can measure the contact angle, higher the angle, higher will be the wetting. Simple. Higher the angle, higher will be the wetting. But for the contact angle is very good for studying clear solutions. If the solution is turbid, in that case measuring the contact angle is very difficult. Remember this question. If the solution is turbid, in that case measuring the contact angle is very difficult. Hence we will go for the Drave's test. Drave's test. What is the Drave test? These are the two things by which you can measure the efficacy of contact angle. Efficacy of wetting. Drave's test is take a beaker of 500 ml. So fill it with wetting agent, some concentration of your wetting agents. Take previously weighed cotton swab. Okay, cotton pod. You can take the previously weighed pod. Check the weight of the cotton pod before dipping into that cylinder. Check the weight of the cotton pod. Put this cotton pod into the solution of wetting agents in some particular concentration, 1%, 2%, 3%, 4%, whatever the percentage you have prepared. You have to keep that cotton pod and the solution of which is 500 ml and in the beaker. Note down the time taken for the sinking of the cotton pod. If the wetting is not good, it will take more time to sink. If the wetting is good, it will take less time to sink. Hence, sink time is inversely proportional to wetting. Remember this. Sink time is inversely proportional to wetting. The wetting is more, the time taken for the sinking will be less. The wetting is less, time taken for the sinking will be more. These are the wetting agents. Example for wetting agents are glycerol, propylene glycol and polysorbate 80. Okay, polysorbate 80. These are the example for the wetting agents. Then we have 8 to 16 Hlb value 8 to 16, which indicates for oil in water emulsifiers. Oil in water emulsifiers. Metallic, I said water in oil emulsifiers are you have metallic soaps which are the lubricants. Okay, we can use this metallic soap like magnesium stearate. It is a metallic soap used as a lubricant in the case of tablet manufacturing. Next is water in oil emulsifiers. So the surfactant which falls in this category will love more water, because we are going towards right, will love more water, hence they will try to keep water as a continuous phase. Then 13 to 16 are detergents. So 13 to 16 are detergents. These are the detergents we will use which will fall under the Hlb value of 13 to 16. Next we have 16 to 20. These are solubilizing agents. They will help in the solubilizing the substance. The best example for this is testosterone is insoluble in body, it can't absorb through the oral route. We include tween 20. So tween 20 into the testosterone formulation. This tween 20 will solubilize the testosterone and it will increase the absorption of the testosterone through oral route. So these are the one example. So the calculation of Hlb values, how will you calculate the Hlb values for given surfactant? We have three methods for that. First method is, if you have a non-ionic surfactant with you, non-ionic. Remember, this is very important question they will ask. For non-ionic surfactant, which method is used for calculation? This is the method. If you have a non-ionic surfactant, in that non-ionic surfactant, if the hydrophilicity hydrophilicity is due to presence of ethylene oxide moieties. Remember, you have a non-ionic surfactant. In this non-ionic surfactant, we have the surfactant is amplified. So, in that amphiphilic nature, hydrophilicity is due to ethylene oxide moiety. In that case, you are going to measure the Hlb value by following formula: E by 5. Hlb value is equal to E by 5. What is E? E is percentage weight by weight of ethylene oxide. This E is percentage by weight of ethylene oxide. So, remember, this is for the non-ionic surfactant whose hydrophilicity, not hydrophobicity, hydrophilicity is due to ethylene oxide. Second one is Hlb value for polyhydric alcohol esters. Polyhydric alcohol ester. If you have a polyhydric alcohol esters with you, use the following formula. So, most preferably used formula is this one. Hlb is 20. Remember, this 20 is the maximum value of Hlb multiplied by 1 minus S by A. So, what is S by A? S is saponification value and A is acid value. Next is, if you have allotted some group, there are group numbers to be given in a surfactant, like how many number of hydrophobic groups are there, how many number of hydrophilic groups are there. If we can know, if the given thing to calculate the Hlb value is groups, this number of groups of 20 number of groups of hydrophilic are there, 40 number of groups of hydrophobic are there. In that case, you need to use this formula. Hlb is equal to summation of hydrophilic group number minus summation of lipophilic group number plus 7. This is the equation used to calculate the Hlb value if the given thing about the surfactant is number of group present in the surfactant, like hydrophilic groups and lipophilic group.